Hey guys, welcome back to another 3D printing video, and today we're going to be checking out the MINGDA Rock 3 Pro. This is a large format 3D printer and I'm pretty excited to see what it has to offer. So in this video we're going to unbox it, set it up, and do some prints. Alright, so let's get started. Alright, so the printer comes in this box and we can see there's a picture of what it looks like. It is quite a large box, and here we have the dimensions, which is 735 by 573 by 320 millimeters. So yeah, and the shipping label says 53 pounds. Alright, so let's go ahead and open it up. So they are using white soft foam and there's quite a thick layer right on top. Here we have a note, I guess, that says do not remove before finishing assembly. I'm guessing this goes on the bed, but for some reason it's up here. So we got our paperwork, looks like quality control and after sales card, installation manual, and it's just one sheet with steps and information on it. And here we also get a software manual, how to use the slicer and setting it up. That's nice that they include this, especially for beginners. This is quite useful. All right, so here we have the power cord. Looks like a pretty good length. A little bag with the MINGDA logo on it. And we got a few things in there. We're gonna check that out in a little bit later. Looks like our spool holder, and there is a filament detector connected to it. Well, that's quite interesting. It's all pre-built and it's all metal. All right, so it looks like the gantry needs to come out next. And this is what it looks like. And the thing that I'm noticing right away is that they're using a larger channel here, or the same size as here, which is a 2040 for the x-axis. That's quite interesting. So this is our theme color. It's like this a lighter orange. And if we flip it around, you can see that we have dual z-axis motors, which is nice, but what's even nicer is that they are tethered together with this belt on the top. And if you're gonna have the dual motors, so this is the only way to go. And I'm really happy to see that they sync them together, so that's really good to see. So yeah, lots of foam here, guys. And I think I've said this before, but I do appreciate, you know, all of this foam, but we got a lot of it here. I mean, it's filling up all this air in this box, and this is a large box. And I feel like there could be maybe a better way to pack these things without having so much foam. But in any case, I mean, it is packed very well. So we got the main base here. You guys almost can't see it, it's kind of low. And also our hot end assembly, which is a direct drive unit, and it's all pre-built and tethered to the printer. It does look like a more open design, but it is a direct drive, so it should work out pretty well. And it appears like we have a dual gear extruder mechanism, so that's nice to see. Interesting cooler with a floating fan that kind of clips onto the cooler. That's also unique, I guess. And we do have a silicone sock on the heat block. Yeah, pretty interesting design here. All right, so now we just need to pull out the base. It is quite large and quite heavy. But the thing I want to mention here is that it does have the ultra base style glass, and I do like this design here because when it works right, it works very well. The prints stick to it when it's hot, and then after it cools they just pop right off. So we're going to take a closer look at all the details a little bit later in the video. And yeah, guys, that is everything for the box. You guys can see that it was packed very well and there's not very many pieces. And so this makes it quite simple and easy for just about anybody to get started with this thing. All right, so before we do anything else, I want to flip this thing around and maybe open the back cover and check out what our electronics look like. So we do have 4 rubber feet on each corner. They are pretty soft, so We got some venting, and there's looks like 10 little bolts to release the bottom plate. So let's go ahead and open this pouch here and see what is included. We got a few things in here. We got our bolts, so the hardware to put the printer together, a USB cable to connect from the printer to the computer, double-sided open wrench, looks like an 8 and 10 millimeters, extra nozzle with a PTFE liner, looks like, another extra piece of PTFE tubing, our full-size SD card, and it's unlabeled or unmarked. And the last item here is our set of Allen wrenches. So let's grab the one we need and go ahead and open up this cover. All right, so all the little bolts are out, and I do want to say that there is a warranty sticker here, so I'm going to go ahead and break mine. So to keep that in mind, I'm not sure how valid it is. I guess it depends on where you live, but this thing literally slots here on the front. There's 2 tabs, so we got to kind of push it out and then it comes out. So yeah, it's just a sheet of metal with some venting here. So. All right, so this is what it looks like underneath. So everything's laid out very nicely. All the wires are routed and organized. So let's go ahead and start from here. So this is where our power input is, and we got an on and off switch. It is fused. That's our Y-axis motor. Going this way, we have the power supply. Looks like everything's connected and even hot glued. It's kind of hard to see, but it's a 24 volt 15 amp. There we go, maybe we can see a little better. So it is 360 watts. So on the other side of the supply, this is where you're going to switch the voltage between 110 and 220. So if you do need to do that, I guess you could go underneath here and change it, but it should be set to, you know, depends where you live, where you bought it, since you're not even supposed to technically be under here. And if we go down from there, we have our main board. And I like how everything is set up here. Everything is quite nicely organized and neat. So we do have integrated stepper drivers. You guys can see them there. And they are supposed to be the silent 2208s, and I'm not sure if they're going to be all 2208s, but I guess we'll see once we power it on. There is an ARM processor, and that's the model name of the board. So yeah, everything looks pretty nice and neat. And we have a ribbon cable here that goes out to our touchscreen display. So yeah, everything's looking good. I'm gonna go ahead and put the cover back on, and we'll flip it around and start the assembly. All right, so we got the printer back around, and before we do anything else, I think we need to check our rollers on the bed, because that'll definitely be easier to do now than later. So there's some foam underneath the adjusting knobs we need to pull out. So let's go ahead and move the bed back and forth and see how it feels. So yeah, I do feel some stepping in it. So that means something's not completely right. Now the way the bed rolls is on these 2 channels with rollers that clamp around it. And on this printer, there's actually rollers that clamp on both sides of the rails. So it is a little bit more complicated to adjust because of that. And there are 2 on each side, so there's a total of 8 of them. 4 for each channel. And so if we lean it here, maybe you guys can see a little better, but right here you can see the 2 rollers and the 2 adjustable eccentric nuts. So this is how you adjust the roller to go closer and farther away from the channel. And the way I check them is I just grab the roller and I try to spin it, and I see what it feels like. So this one actually feels really good, and this one is too loose. So the idea here is to have a little bit of friction as you're spinning it in one spot. If you can't spin it at all, that means it's too tight. And if it spins too loose like this one, it just spins without any friction. That means it's way too loose. So I'm gonna go ahead and stick my hand on the other side and feel what that feels like. And the other side's actually feeling pretty good. It's a little bit on the loose side, but I have a feeling that it's going to be perfect once I tighten this very loose one up over here. Actually, the bed is pretty decently adjusted, which is interesting because it is loose enough technically by just feeling them, but I still have a little bit of steps here and there. So this might have to do something with effective roller or maybe the channel. Let's go ahead and tighten the loose one here. So we're just gonna grab our wrench that was included and gonna turn the eccentric nut in there just a little bit to tighten it up a little bit more, and that's perfect. And so I know for a fact now that the rollers are adjusted perfectly and there's no issue there. But yeah, the point here is that you adjust the rollers where they have just a little bit of friction on all of them, and you should glide really smooth. So let's go ahead and go to our manual here. So here we have a picture of all the main parts that we're going to be assembling, so you guys can see it's quite a simple process. So we do have to fold it out so we can see the whole thing, because it goes like this. So we're going to go from here to the step 1, and step 1 is installing the gantry, and we are going to need our M545 bolts, 4 of them, and also 4 of the M420 bolts, and everything is in this little bag here. So we got the 4 long bolts, you can see right here, and then we need 4 of these bolts here. All right, so this part is not very hard. You guys can see there's a bracket here that's pre-installed, and right behind the bracket right into the frame, there's a hole here, and this is where the gantry is going to literally slide into. And then this bracket here will have 2 bolts that go through it into the upper portion of the frame on the gantry. And it's the same way on the other side. So yeah, we're just going to grab our gantry with the front going to the front, which the motors here go to the back. Simply just set it in there. So we're just going to line it up, and then it falls right in. Goes all the way down, and it pretty much holds itself right now. And the way it mounts is actually quite unique because we have 2 larger bolts here and then 2 smaller bolts on top. So the larger bolt goes there, and then the smaller bolts go above that. And then we're just going to simply tighten them up. So yeah guys, they made it really simple to put this thing together, because a lot of times, you know, these larger bolts have to go from underneath, and looks like on this printer everything goes through the side. And that actually makes more sense for rigidity, because the way this thing's built, its weaknesses is back and forth, and this will eliminate that because you have a lot of strength, back and forth flex in this design. And you really don't need much of any kind of flex this way side to side because of the frame. It's boxed and there's not much weight that's causing it to go side to side. So yeah, I'm pretty impressed with how printers evolve over time, and this printer here is definitely using a better design than normal. All right, so I just kind of run those down and haven't tightened them all the way, and I'm going to do the same thing for these little ones higher up. And the reason we don't want to tighten it up all the way is because we want to start the other side first. You know, just in case there needs to be a little give here and there, we're not really forcing anything but letting it kind of sit where it wants to. Yeah, same thing here. Pretty simple process. All right, so we can go ahead and tighten this side up all the way. Now be careful not to over tighten the little bolts because they are small, so you don't want to break them off. And the larger ones, obviously we can tighten a little more. Now we can go back to the other side and tighten these all the way. All right, so yeah, that part is quite easy and simple. So for step 2, we're going to be installing the junction box. And if we're looking at the printer from the front, it goes right here to the left side, right on this area here. So you want to make sure that your main wire here that's coming out of the control board there is not tangled. So, you know, you spin it either way you think it needs to go. And inside of the box, we have a couple plugs that we have to plug in. Well, I guess there's 3 total. So there's an actual motor plug, and I don't think we plug that in right now, but there are 2 little plugs here, red and black wire, and they go on this little switch here. So this is the X-axis end stop switch. And so we're just simply going to slide them over just like that, if you guys can see maybe. And so this other plug that plugs to the motor actually just comes out the back here on the edge. And this whole little junction box mounts to the frame. There's 2 threads here, and there's 2 little ears on the box where a bolt goes through. And that's going to be these 2 little guys here. Now remember that this white motor plug has to actually come out of this corner here, so it can go to the stepper motor here in the back. Yeah, just like that, the little junction box is on. Quite simple, not too hard to figure out. Now for step 3, we're going to install the direct drive hotend assembly to these carriage here. And if we look at the back, we can see there's 4 threads, and they're just simply going to match up with the 4 holes here on the carriage. So again, you want to make sure this wire here is nice and straight, and this simply will just sit over just like that, and then the bolts will go from the back. And here you guys can probably see the 4 little holes on the carriage, and we are using the same 4 bolts as we did on the junction box. Yeah, we're just gonna line it up and start the bolts. Once we get all 4 of them in there and started, we can go ahead and snug them up. And these don't need to be very tight. They are quite small, and there's 4 of them. So yeah, that looks good right there. All right, so let's go to step 4, and that's installing the spool holder. And if we go straight up, it's going to go right here on the left side of the printer. So if you're looking at it from the back, it's on the right. And so grabbing our spool holder here, it's literally going to sit just like this. So the spool part of it is going to go to the front. So we're looking at the back here, and it literally sits in just like that. I'm going to give you guys a better view in a second here when we go over the printer. There are 2 threads here in the channel, and we're going to use the last 2 bolts that go through the holes here into the top channel to hold the spool holder. So yeah, just like that, the spool holder is on. So for step 5, we're going to plug in the filament detector that's on the spool holder. And step 6 is the rest of our plugs also on the printer. So here you guys can see the filament detector, and there's a little plug on it on one end. There's a wire coming out of the channel that actually travels from the bottom. And all we got to do here is just plug it in, just like that. And so our spool goes on here, and then the filament will go through the filament detector down into the direct drive extruder. So if we go down from there, right over here, guys, you can see we have another plug here to plug in, and that's going to be that filament detector wire going up. So we're going to plug it in, but we got to make sure that it stays out of the way. It's a little bit long for some reason. I guess I can pull it out on the top, so that's what I'm doing. If you guys can see that, it's going disappearing into the channel. I think that's the best way to do it here. And all I did is just pull it from here, so you know we can get the slack out from the bottom, and here we can kind of deal with it a lot easier since we have more room, and it technically should not be in the way of anything. Actually, I'm going to adjust this little trim piece to go back a little bit so I can hold the longer wire here. There we go. That's beautiful right there. All right, so going back down here, we have a few more things to plug, like this wire here that came out of this junction box. It goes actually in the X-axis motor. The plug is right underneath it. Plug that in. And then if we go around to the back, you can see that we need to plug in the Z-axis motor, and the plug just literally comes out from the base, and just like that. So everything is looking good so far here. We can see that our hot bed is already connected. If we go to the other side on the Z motor, we can see there's another plug here that we can go ahead and plug. And believe it or not, guys, that is everything with this printer. So for step 7, it shows us that we need to adjust the rollers on the Z-axis rails, and then 8 on the bed, which we did already. And then step 9 is to plug it in. So yeah, we're almost there. So let's go ahead and check these rollers on the sides, and they actually feel all perfect. So on my machine, these seem fine, and they don't need to be adjusted at all. But if you do need to adjust them, the eccentric nut here is on the inside of these 2 rollers here. So again, use the same method as we did before, where you can feel the roller have tension, but it can still spin around. But don't worry about these as much, because they're not as critical to be perfect, because we do have dual Z leads that operate them both together, and plus we are tethered on top. This doesn't make it extremely too critical to get these things, you know, if you're having trouble, get them close, and that should be good enough. And in this printer's case, probably a looser is better than tighter, since we have the dual Z's. Now what is quite important is these rollers here, because this, you know, drives our main extruder here. And because this is a direct drive extruder, it's quite heavy. So normally these I would recommend leaving them quite loose, but on this one, you want them to be a little bit tighter, meaning that your roller still should spin easily in one spot, but have a little more tension, because we are carrying quite a bit more weight. And on mine, guys, it's adjusted perfectly. It's quite good. So yeah, looks like they got my printer here adjusted very well. But if you do need to adjust it, the eccentric nut is from the bottom, and you can move the Z-axis up and down by just spinning one of the couplers here, and you guys can see the other one spins with it. And the reason for that is because the belt on top is tethering them together, which allows it to spin together. So yeah, and you can get to this eccentric nut under here. All right, well, I'm pretty happy about everything here. Very nice and smooth. Now another thing that's quite important is you want to check all your belts. So you want to check your Y-axis belt like we talked about earlier, and your X-axis belt. Now another interesting thing about this printer, well, I guess a nice feature, is that it does have the adjustable tensioners with the little knobs here, so you can, you know, go tighter or lighter on the belt. And we do have for the Y also here in the front, so we can see how tight that is and, you know, adjust it accordingly. So you want to be careful not to make it too tight, especially on these knobs. You can't really feel how tight it's getting, but it's probably going to be crazy tight. So the way I like to do it is go completely loose and then kind of tighten it as I feel it. And then when it starts to, you know, just ever so slightly to get tight, or I guess get, you know, firm, then I'll leave it there. So this is a large bed, so you might want to, you know, have it reasonably tight, but don't over tighten it. Same thing for this guy here. Mine feels like it's too tight, honestly. Actually, guys, on the X-axis, you do have a locking set bolt here that keeps it from moving it around. So you got to loosen that first, and then you can tighten it or loosen the belt. So yeah, once you get it where you want it, then you can lock it back in, and now this won't do anything really. So I kind of like that design better than just having it on its own, because, you know, that keeps it from moving around by accident, tapping it, or just vibrating, you know, looser or tighter. So that's nice. That's a very good implementation there. So all right, well, I think, guys, that is basically everything when it comes to installation. I'm gonna go ahead and move this up a bit, and we can go ahead and remove this plastic cover on the bed. Now, you didn't want to remove this earlier when you first started assembling, because you're going to get your hands greasy. Right now, mine are a bit greasy from just touching the printer, and the lead screws are actually greased. So yeah, you want to keep away grease or anything off of this bed, because if you get grease on it, you're going to have trouble with it. So they did tape plastic cover right on top here. That's honestly a little bit harder to get off than it needs to be. So yeah, it looks like the build platform is permanently attached to the bed, so there's, you know, no taking it off or anything like that, which is totally fine. Most of the time you don't need to do anything to this kind of build plate anyways. It looks pretty nice, and instead of being black, it's got like this nice gray look to it. But let's go ahead and take a closer look at this printer and all of its features. So looking at it here from a distance, it's quite a large footprint. And this table that I have here is, you know, a large size and does take quite a bit of room and quite tall also. So starting here on the top, we can see the spool holder, quite an interesting design. I like that it's all metal, so it does feel reasonably sturdy. We have our filament detector here, which should go straight out of the spool down into the extruder assembly. So now we're looking from the back on the top here. We can see how the spool holder mounts and these two bolts here into the channel. And again, they're using a larger channel on top here also than normal. So here we can see at the ends, we have metal brackets that hold bearings and gears also on both sides that tether with this belt in between. And I'm really happy to see that they've done this, because this is definitely the way to do it on a dual Z axis. So going down, we can see we got a pretty large distance here because we have 400 millimeters of printing volume going up. We can see the brackets here, they're all metal, quite thick metal, so it's nice and heavy duty. You can see our brass bushings here and the design of them with anti-lash springs, so this keeps it from just falling down. We got our X-axis motor and the plug that we plugged in that comes out of this box. Going down, we have the Z-axis motor with the couplers here. And here you guys can see how the gantry mounts on these 4 bolts, 2 smaller ones and then the 2 larger ones. And going to the other side, pretty much everything's similar here with the other Z-axis motor. Now looking at the X-axis, this part here is thicker than usual. Usually they use the 2020s here, but this is a 2040. So yeah, that's gonna give it a little more stability from not rocking around as much. And on the bottom here, you can see that the adjustable wheel here has the eccentric nut down on the bottom. So yeah, this is our hot end, which we saw earlier, and the actual parts cooling fan here blowing right underneath. It's nice that it has a silicone sock, so yeah. Going down to the bed, we got the build platform that's permanently connected. We got strain relief connection to the bed, so that's nice to see. That's very sturdy. And looking underneath, we can see that the bed is insulated, so that's really nice. I was hoping that it would be, and it is. And for this size bed, you really want that. Pretty large adjustable knobs on 4 corners with high quality tension springs. On the very back, there's nothing here. It's just a clean frame. And looking from the top, you can see the 2 rails, the belt, the motor is right underneath there. You guys can see the pulley, and that's our end stop switch for the Y-axis. So now going back to the front, we can see our junction box that we installed, and then our X-axis end stop switch we plugged in inside. The hot end assembly with the extruder all built in one, so it is a direct drive, and it does look like we have the dual gear extruder with the heat break here that's cooled off by this fan. And behind this metal plate here, there's the extruder motor and our parts cooling fan underneath that. So on this side, we can see we have the adjustable belt here, and that was the little screw there that I was showing you guys earlier to lock it in, and we got knobs here to adjust it. So going back to the other side, we can see we got a pretty large screw here, and this adjusts the offset from this switch down here, which is the Z-axis end stop switch, and that's what stops the printer from going down, and you can adjust that lower or higher here. And speaking about the bed, this is what the finish looks like. So it's kind of like a gray look, so I think it's just more transparent. That's why it looks more gray than black. So you can kind of see the bed bolts on the inside. Nice little logo here. Interesting little markings on the 4 corners. Our rail with the belt and the adjustable tensioner, and this one actually looks the same as this tensioner here, but if you guys see the set screw, the way it is, it actually ends up being underneath the printer, so it's not used. It's nice that it is adjustable though right here on the front. And going to the front, we can see that we got the logo, the name of the printer, Rock 3 Pro. This is where we're going to plug in our full-size SD card and the USB connection to connect from the printer to the computer. And to the left side, we have the display, which has a protective coat. Let's go ahead and try to pull it off. All right, so that one came off pretty easy. So it's a nice, good size screen. And also guys, if you notice, this printer has a really low profile kind of base. So it does look pretty nice. It looks quite thin and sleek. But yeah, if we go to the left side here, we can see we just have some venting holes and the main wire that comes out. And going to the right, we also have some venting. To the very back here, we have a manufacturing label. It tells us the model of the printer, the print area, which is 320 by 320 by 400 millimeters, the power it uses, and some other information with a QR code. So here we can see the power switch on and off. It is fused, and that's where we're going to plug in our AC power. So yeah guys, overall pretty nice looking printer. It is large, keep that in mind, very tall, and quite heavy also. And it is all metal, and that's probably why. All right, so we're pretty much at the place where we can go ahead and plug in the power cord and power it on. But before I do that, I want to make sure that the nozzle here is not going to hit the bed, and this is, you know, quite important. So the thing we're looking for here is the in-stop switch here needs to click before the nozzle, you know, gets too close to the bed. And we're going to just run this down all the way, and I'm just using the belt on the top there to turn it. Clicking the button, if you guys can see that, but yeah, we're gonna run this down just a bit, just so we're more in the safe zone. And now we're definitely clicking the button before we get too close to the bed, so we can always adjust that up or down as we need it. All right, so I'm gonna hit the power switch. All right, it boots up. Okay, good. So yeah, it looks like we got a little light here. We can see something glowing. The main menu is booted up and everything seems to be fine. So the first thing I like to do is home the printer and make sure everything works. So let's click on menu here, and then we're gonna click home and then home everything. And let's see. All right, so X and Y. So X is good. Y is good. And Z looks good too. All right, so all of our axes work, and also they were all quiet, at least what I could hear. So yeah, it looks like we do have silent stepper drivers in this printer. Now the next part is probably quite important, and that's going to be a leveling of the bed. And it looks like this printer doesn't have any kind of automatic bed leveling. Not that I can see here. So what we're gonna have to do is we're gonna have to home it and then manually move the hot end assembly around to each corner of the bed. So even though it homed, let's go ahead and home it again just to make sure it's just right. So you are going to need some kind of paper, and I'm going to use this do not remove paper that was with the printer, and that looks like maybe what it's for, I don't know. But in any case, so after that we're going to click on this big X, and that's going to release the stepper drivers, and now we can move it manually. Now you want to be careful not to push down on it because we're trying to hold the same level as we're adjusting the bed. So you're going to move the X back and forth gently, and then the whole bed also. So let's go ahead and start with this corner here. So we're just going to go to the corner, and then we're going to use the knob to adjust it and move the paper around here until, so yeah, there's a little bit of friction here. So yeah, let's go to our next spot, which is going to be over here. Same thing here. And there we go. Now go into the back corner. It's good. And this one is too tight. Fix that by tightening the knob a bit to make the gap bigger. Now we're going to go back to the first corner, and we can see that it's not good anymore. So you're gonna have to go around at least 3 or 4 times until you get it just right. And so all you want is basically just a small slight drag in the paper between the bed and the nozzle. So, and you can use any kind of sheet of paper you want. Like a normal print paper would be just fine also. And actually guys, as I'm doing this, I totally forgot. We need to go ahead and preheat the bed so we can adjust it, because when the bed heats up, it does expand somewhat. So let's go ahead and click on bed here, and we'll hit the plus. And it goes straight to 55, so let's just go to 60. So now the bed is warming up. I guess we can go ahead and also check, make sure our hot end works. We'll heat that up to 200. So our bed's heating up, it's at 30, 31, and the hot end is also heating up, it's at 40, 43. So yeah, everything seems to be working and heating up. So as it's heating, I'm gonna go ahead and keep adjusting because we do need to get this thing pretty close to precise. And so once you go around enough times and you feel like everything is pretty close, obviously the more you fine tune it, the better. You'll have a more even surface, but you wanna get, as close as possible on all the corners, and then we can go ahead and check the middle. Now a lot of times the middle is going to be, or the center is going to be a little bit looser than the corners, and that is the case here also. So if that's the case with you, what we could do is we can turn each knob a certain amount, and that'll bring the whole thing up or down. So I'm going to turn it just a quarter of a turn on every knob, and that should bring us up, and sure enough it is. And that might have been too much, so I'm going to go back, so more like an 1/8 would have been enough, and that is actually perfect. So yeah, make sure you take your time and do it right. And if you have to, keep going around and around until you get it really close, because this is quite important to make sure you get the print to stick to the bed. All right, so I'm kind of curious what we have here on this SD card. So it is full size, but it is unmarked. Let's go ahead and plug it in. It does go upside down, looks like. And we're going to click on print, And here we can see some folders, and we do have a folder called G-code. Okay, so there is a couple files here included. Some kind of cartoon Halloween pumpkin and Superman half body. I think I'm going to go with the Superman here, but I wanted to make sure that we have something to print. So before we initiate that, what we need to do, let's go back here, is put some filament in. But if you guys notice that this printer didn't come with any kind of sample or anything, so we're going to be using our own filament here, and this is just red PLA. So looking on the top here, the spool will sit onto the spool holder like this, and then our filament will go through the detector. And the detector does have a little light that glows, indicates that's detecting. And then from there we're going to go down into the direct drive extruder. And so on the extruder here we do have an adjustment for the tensioner, but yeah, we're just simply going to pull on it like this and release it, and then the filament will go straight through. See, I probably need to go up a little bit here so we can see better. But yeah, if we release the tissue from the clamp, we can just manually push it through and purge it like that. You can see the red coming out. Or you can go in the menus here and click extruder and then load, and it will push it through. So yeah, you can choose normal, fast, and the amount. So you guys can see there. In any case, you can use that if you want, but it's much easier just to, do it yourself. So. All right, so I think we're almost good to go here, but before we start the print, let's check out the UI here on the printer. So this is what we're presented with. We got the nozzle, so we can adjust the nozzle, and we also have a readout there of what it's currently doing. So if we click on it, we can adjust all the increase and decrease the temperature and stop the heating and adjust how much increments we want to adjust. And then if we click on the nozzle, we can actually go from the hot end and the hot bed, so that's pretty convenient. So, but we also obviously have our own hotbed here too, which we can go back and forth. So we got fan controls here, our speed controls, and then we got our menu button here and our print button, and then information in the middle. So the menu button has more options like moving the printer around all the axes. Then we got the home here. We can home each axis or all of them at once, and then this stops everything. Actually, this is an emergency stop, so I guess I was clicking the wrong thing when I was trying to disable the motors. In any case, so we have the extruder button here, so we can, extrude. The print, this is going to read our file, the SD card, and settings. In the settings, we can control the screen here, so we can rotate it, more adjustments, the languages. Okay, so Dutch, Italian, Spanish, French, and back to English. And then we also have the volume control, so we can, or I guess the beep, we can either have it to beep or no beep at all. So right now it doesn't do anything. I think we'll leave that on for now. The run out sensor, you can turn that on and off, so we're going to leave that on, and info about the printer. Alright, so yeah, pretty straightforward here, nothing too complicated. So let's click on print and G-code here, and we'll click on Superman, and there it goes, and it started. So after it starts printing, we'll go back here and check out what we can adjust as it's printing. Alright, so it looks like it's moving around. Alright, there it goes. So it does appear that we are good off of the build plate. We're not scraping into it. Wow, that looks like a pretty large model, or at least it appears to be. Okay, well, this might be a really long first print. I guess we go ahead and print something here. Hopefully you guys can see there a little better. But yeah, it looks like it is building a big raft. And the printer is actually quite quiet. I'm gonna bring in my microphone so you guys can hear it. So yeah, quite impressive of how quiet it is. So it looks like we do have silent stepper drivers on all axes, at least what it seems like so far. So mostly what you hear is just some fan noise, and it's not even that loud. Now there is some kind of distinctive little buzzing sound, like I don't even know what it is, and I'm not sure if it's the fan or maybe the power supply or something. Something's buzzing a little bit, and it almost sounds like crickets or something. But yeah, other than that, it's, I would say, definitely on the more quiet side, and actually more quiet than most printers. So let's go ahead and look at the UI here as it's printing. So on the very top, we can see the file name. Then we got the pause button here, the progress bar, and we can see here the coordinates of the X and the Y axes, the percentage bar here of how much is completed, and then on the other side we have a big stop button And underneath the percentage bar, we have the temperature of the nozzle. It's interestingly only at 185. I don't know if I should bump that up or leave it the way it is. I guess I'll leave it. And then the bed is at 51 right now, but it wants to be at 40, interestingly enough also. So I guess we'll leave that. And then the time that's passed, which is about 5 minutes now, or almost 6. And then the Z-axis height there. So here we can control the heat if we click on it. And I think I can bump this up a little bit. 195 seems more reasonable here. Let's go back. Actually, let's go back to the heat and we'll change the bed also to 50. I think that's going to be quite reasonable. So here we have percentages. So this is our speed. We can increase it and it'll go faster or decrease it to slow it down. So here's a good one. This is Babystep. So here you can adjust actually to go up and down. So when you first start printing, you can actually fine tune it right here. You can do 0.1 at a time, 1 or 0.01, which I think is the one you want. So you can very tiny little baby steps up and down. So if you need to go up a little, you can, or a little down. So that's a nice option to have. Then we got a more here, and for more we got fan controls and then extruder controls. So if you want to change your filament during the print, you can do that here too. So, or adjust the fan, obviously, same way. But in any case, yeah, pretty good options here and a lot of good information. So yeah, it looks like our print is printing along and everything looks fine. And if you guys can see, there's a light in the background there, and I guess it's an RGB LED light that keeps changing between colors. So yeah, it's pretty unique, I guess, and kind of makes it more interesting looking. And I don't think there's any control for that, so it just kind of stays on. But I kind of like it. It kind of gives it a little flavor. So yeah, we're gonna let this pretty large print here print, and hopefully something good will come out of it. And we'll see what it is. All right, so a bunch of hours later, and I think, you know, it's like 15 plus hours it took to print this, which is kind of understandable. It looks like a pretty high resolution print. So let's see how easy it comes off the bed. All right, well, that was very easy. It just popped right off. So the bed did cool completely, so it's kind of almost ice cold. It is a cool morning, so the print was printing overnight. You guys saw how easy it came off, and this is what makes these beds so awesome and why I think they permanently attached it, because you never really have to do anything as long as you have your spacing right between the bed and the nozzle. Let's take a closer look. So overall, he looks pretty good. I don't see any kind of layering or anything funny. There is a little bit of retraction stringing here. I do notice that we do have a little bit of vibrations on the y-axis, and that's probably because this bed is so large. There's a lot of weight to carry, and plus I did have my little GoPro attached to it, so yeah. So I was expecting a little bit of ringing and things like that, and we do have some, we can see. But other than that, guys, yeah, the print turned out really nice. Overall, it is in red, so it's a little bit harder to see all the layers, but as far as the print quality goes, it seems to be really nice. It did print a raft. Let's see if this comes off. No, it almost wants to come off, but it doesn't, so I'm not gonna force it. All right, well, I guess that was a pretty good start there with the Superman file. It did take a little bit too long. So for the next part, I think what I'm going to do is I'm going to slice a calibration cube and a benchy, print those out in silky black so we can really see the reflections. And with that, we'll be able to see a lot better of how this printer does. Alright, so the calibration cube and the benchy are finished, and let's see what they look like. So we'll start with the calibration cube. So here we have the x-axis. Looks pretty good. There's some vibrations there, but not too bad, and a bit of ghosting, but not terrible. Let's go to the y. So the y has a lot more vibrations, and looks like ghosting too, so yeah. Now, I might have had the belt a little tight on this, but I'm not sure. I did loosen it for the benchy, and we'll see what the difference is there. So this is the X wall, pretty good. And the Y wall, which doesn't look as bad as the Y itself. And maybe that has something to do with direction changes here also. So I guess more on the ghosting. The Z and the bottom looks perfect. Let's grab our calipers. They're zeroed out. All right, we'll start with the X and measure that. Pretty darn close. Let's go with the Y, also pretty close, actually right on the dot. And the Z, very good also. Wow, so yeah, very accurate as far as dimensions. So yeah, except for the Y being a little bit ringy there and ghosty, I think overall this is a pretty solid little cube here, and the accuracy is great also. Let's go ahead and see if we can look at the benchy. Actually, the bed is still warm and just finished. Oh, it still comes off. Wow. So yeah, you guys can see on the bottom, it does look like we do need to be a little bit closer to the bed because we were there in danger a bit of popping loose. So I am going to adjust it just a little bit. So thankfully this didn't pop off and it completed. It's quite incredible. And this bed grips really well. Then as you saw, it pops right off. So the benchy looks good. So we can see how the layer is sitting really nice. Very minimal vibrations. Pretty nice, smooth here on the front. And over here we can see some ringing. On the walls here on the x-axis, everything looks pretty good. Retraction looks decent too. Cooling is good. And here we can see the Y. So yeah, the vibration is still there on the Y, guys. Even though I did loosen the belt just a little bit. We do have a slit in the box. Let's go to the other side here. Here we can see it's a little bit rougher. And we can really see the ringing on this end here. So, and this is our stitch right here. But overall, guys, it's pretty good and quite solid. A little benchy, and we practically have no stringing of any sort. So yeah, the direct drive seems to work very well. So overall, I think, you know, it did a great job. We are printing, by the way, I didn't mention, at 50 millimeters a second, 0.2 layer height, with 200 on the nozzle and 60 on the bed. So the cube took less than 30 minutes, like 28. And the benchy only took 2 hours, or a little under 2 hours. So yeah, that's, you know, a pretty quick print for a large printer like this. I want to go ahead and print more models. Also some spiralized for larger, full 400 millimeters tall. So that's going to be quite interesting. And then we'll take a closer look at those, and I'll give you my final thoughts about this printer. Alright guys, so these are all the prints that we printed, and the printer performs very well. I had no issues whatsoever with anything, and everything just works. So we've seen the Superman, the benchy, and the cube. And by the way, I made a little error with the cube and the benchy. I actually printed those at 60 millimeters a second, faster than even I thought. So that probably explains why the vibrations and ringing was a little bit higher. So in any case, the rest of these prints were all printed at 0.2 layer height with 50 millimeters a second. So let's go ahead and start with this little frog. And unfortunately, the frog lost his legs. They were still stuck to the bed as it was printing, but something between the leg and the body messed up. I almost think it was a G-code error or something. If we ignore his front feet there and just look at the finish, we can see that underneath here, this part turned out really nice and smooth. And this is not always the case on all printers. So yeah, and you guys can see the body is really smooth also. So we got stitching up here. That's what those little lines are there. And if we look at his little feet here, they turned out really nice too. So this is a pretty delicate model and not always, you know, easy to print. There is a little bit of under extrusion on this eye, and that might have to do something with retractions. As far as stringing or anything, that's all good there. And we're at, I think, 6 millimeters retraction speed. So we could probably bring that down and maybe avoid the under extrusion. Since this is a direct drive, probably should put it down to like 3 to 4 millimeters. So I would like to print this bearing here, is what it's called. The thing that makes this a pretty hard print is that it is functional. And if you guys see, if I hold the middle, I can spin the edges here. And it's not perfect. Got a little stiffness to it, but there is no play in it, almost at all. So it's very precise. But it does spin, which is important. But not only that, the precision on it is excellent. So yeah, this printer did a very good job there. Now we do have a little bit of layering here. There was some lifting and shifting. So apparently the print wasn't sticking very well to the bed. Speaking about that, it did seem to stick fine in the beginning, but when I started printing this print, shortly after, it lifted off. And I was kind of confused why, and then I realized there was quite a bit of fingerprints from my hands, and just me setting my hand onto the bed, I guess transferred the oils from my hand into the bed, and that was causing it not to stick well. And so if you have any trouble with the bed and sticking, the way to fix it is just use regular water with a slight amount of soap and just kind of wipe it off, and then go back, clean it off completely with just a wet napkin, just water, nothing else. So after I did that, the prints all stuck extremely well. So let's go ahead and check out the octopus here. And the octopus shows us here that, number one, we can stick to the bed just fine because we have a lot of very small individual pieces that have to combine together into these legs. And as you can see guys here, there's no issues with that whatsoever. So and plus we have tolerances which are really good. All the legs move nicely and there's nothing funny, no stringing, no blobs. There is a slight under extrusion here and there, and again I believe that my retraction on the extruder was a little high, meaning that it pulled the filament out way too much, and then when it pushes it back in, you know, it's not completely coming out as it's supposed to right when it starts going again. We got really nice layer adhesion, practically no layering of any kind, so very nice reflections. Small model with, you know, lots of detail, and this printer did a great job. So the other thing we printed here is this box, and this is a spring-loaded box designed by a guy called Sunshine, and he does have his own YouTube channel. And this is pretty cool because, you know, we have a mechanism here with a lid, a hinge, and this is all just one print. I did close the lid, and to open it we just hit this button here. It doesn't open all the way, and the reason for that is because I left it closed, and that eventually relaxes the spring. So if you want it to work good, you want to leave it open like this, and then it'll pop up all the way. So, but in any case, it is a box, and it is pretty cool, I guess, the whole design and how it works. But because PLA relaxes over time and conforms from heating and cooling, you know, if you keep this closed, eventually this will barely do anything. So if you want this to be useful, you might want to use something like PTG or higher temperature filaments that will not deform so easily. And by the way, it did print just like this. So. And our two last prints is the astronaut and the spaceship. So let's take a little quick look at the astronaut. Now this print didn't turn out as good as it normally does, and there's a reason for this. And you guys can probably see it's quite layered and it's got a lot of under extrusion here and there. And so what happened here was the filament was running out off the spool, and so at the end of the spool it was kind of tangled, and so it had to like snatch itself out as it was printing. So there was a lot of stress on the extruder to pull the filament out because it was jammed and things like that. But surprisingly, it still finished and turned out pretty decent overall. So I think I have to get rid of this spool of filament because it's just not usable anymore, and it's almost running out. So this is why we had a little bit of trouble. But if you guys look at the reflections, you can see how even everything looks. So again, we do have some vibrations on the y-axis, and you guys can see here and right here a little bit on the filament. So, but it's not bad at all. And also guys, testament to this build plate that, you know, this is a small amount of surface area to stick, and it stuck very well and finished this astronaut. And so our last print here is the spaceship, and this is actually in spiralized mode, and it's also 400 millimeters tall. So yeah, this is the maximum length that this printer can print going up. So let's look at the bottom. We can see it looks really nice. And going to the sides here, so in spiralized mode guys, this printer did extremely well. You can see how good the layers are sitting, and there's really not too much vibrations or anything funny. So very nice even layer adhesion on the boosters here and going up. It's really good. And you guys look at this window here, it's quite reflective too. So this part here always has a little bit of artifacts, but I think this just has to do with the model since it's scaled up so much. And as we go up, we can see it only gets better, and this part here is just beautiful. It's perfect. A very nice layer adhesion there. And as we go up all the way to the top, we can see that we had a little bit of melt here, and this is pretty common, but I would have liked to see a little less melting, but the ball still printed and didn't melt at all there. So yeah, so this is one layer all the way up, and the bond is really good. If I flex it, you guys can see it doesn't break or pop. So yeah, obviously if I push too hard, it's gonna break, but overall it's a good print. And you guys saw how easy it just came off. I actually never removed it from the plate yet, and when the plate got cold, it just came off. Again guys, this is what makes this kind of build plate very nice, is that it sticks when it prints, but it pops off when it's cool. Now you might have to wait till it completely cools, so that's a little bit of annoyance. And also another annoyance theoretically could be if you lose power, your model is probably going to pop off when you do go to resume the print again. So that's the only really negative about this kind of bed. But other than that, it's great, and 99% of the time it's exactly what I would want. So I think this printer has a lot to offer. It really has all the features that you would want, and also the build quality is really good, so you really do get a lot with this thing. And the build volume being 320 by 320 by 400 really gives you a lot of room to print on. And also it have filament detection. You know, if you run out of filament, it's gonna alert you, which is quite important if you're doing a really large print. We do have a direct drive hot end assembly that works very well. And also the dual gear drive is pretty precise and nice to see that it's on this printer. Also really nice is the silent stepper drivers. So the printer is pretty quiet overall, except for some fan sound. Also we get dual Z-axis motors with leads that are tethered on the top, so that's great. And probably the best thing about the Rock 3 Pro here is that it is quite simple to put together. So if you're just getting started with 3D printing, or you know, you don't want to mess around with too much assembly, this thing is quick to put together out of the box and get started. And not to mention how well it's built and how all the frame connects. And we do have thicker channels on top and the X-axis here, so I think the Rock 3 Pro here somewhat deserves the Pro name for what it is, at least comparing it to other Pro machines. As we know, the Pro name has been overused, and I'm sure we'll be moving to something else soon. But I find this printer very friendly and great for anyone that's just getting started, or you know, if you need an extra printer or wanted a large format. This printer really delivers on all aspects. So if you are interested in picking one up for yourself, I'm going to have some links in the description. Check it out. And if you enjoyed this video, then hit that like button. If you want to see more 3D printing videos, I got a pretty large playlist of printers I've reviewed. Check it out. And also stay tuned for more videos coming soon. And if you made it to the end, thanks for sticking around. And as always, thanks for watching, and I'll catch you on the next one. Peace.